All right, let's take a look at question number 4. We're to sketch the graph of the given piecewise defined function. So we have two lines that we're graphing on two um, planes. So let's go ahead and label the lines that we're graphing. So we have line number 1 is going to be on plane 1, and then line number 2 is going to be on plane 2. Now, the partition, the line that separates our two planes, is going to be the line x equals -1. Okay? So let's put down the information that we need to graph our lines. I'm going to make the information for line 2 in green so we can keep them separate. So for line 1, this is our equation right here. Y equals x plus 3. So the slope is 1. So that tells me that the slope is going to be 1 over 1. I'm going to rise 1 and run 1, starting from the y-intercept b, which is positive 3. Now I'm going to take a look at the second equation, y equals 1/2 x minus 2. For this line, the slope is 1 over 2. We're going to rise 1 and run 2, starting from the y-intercept of -2. Okay? So we're going to restrict the graph of line 1 to plane 1, and then the line of graph 2 to plane 2, basically to the left and the right hand side of the line x equals -1. All right? So let's go ahead and graph our lines. Let us set up our coordinate system, the y and the x-axis. Our partition is going to be on the line x equals -1, which is right here. So I'm going to make it a dotted line. Okay, I'm going to start by graphing line 1. For line 1, we're starting from positive 3. On the y-axis, I'm going to rise 1, run 1. That's another point that defines the line. I can drop 1, fall back 1, drop 1, fall back 1. Now, when I'm graphing the line for line 1, I'm going to ensure that I restrict myself to the left side of my partition because x is less than -1 when this function is active. Okay, so let's go ahead and draw that. So that is line number 1. Now let's graph the second line, line 2. The y-intercept there is -2, 1, 2. It's -2 down here. We're going to rise 1, run 2, 1, 2. Rise 1, run 2. So these are the points that define the line that lies in the second plane. Okay, so let's go ahead and draw that line, starting from the partition all the way through the lines. Okay, so one thing you want to note is what happens when the lines hit the partition. Okay, what happens when these lines hit the partition? Since this line does not have an equal sign underneath the inequality, that means that this point is excluded from the line. Okay, so in order to indicate that exclusion, we have to put an open circle at the point where this line touches the graph, touches the partition. Okay, so we put an open circle here, which means that this point is excluded from the graph of our piecewise defined function. The same applies to this line also because there isn't any line of inclusion here to include this x value in the graph of line 2 or line 1. All right, so there goes the graph of our piecewise defined function as indicated above. Let's take a look at question number 5. It says given f of x equals 3x minus 1 and find f inverse and verify that f composed with the inverse and the inverse composed with f equals x. Okay, so we have 3 parts to this problem. Let's start with the first part, part 1. Part 1, we are to find f inverse, the inverse of this function. So for symbolic convenience, I'm going to write f of x as y equals 3x minus 1. To find the inverse, we'll simply switch x and y. We have x equals 3y minus 1. We'll isolate y, and our new y will be the inverse. Okay? So let's go ahead and do that. You add 1 to both sides. You have 3y equals x plus 1. Divide both sides by 3. You have y equals 1/3 x plus 1 over 3. All right? All right, so we'll say our inverse, we're going to call f inverse of x, 1/3 x plus 1 over 3. Okay, so that's the answer to our first part. Okay, now after finding the inverse, we have to verify that this inverse is in fact correct by composition. Okay, so let's go ahead and carry out part 2. For part 2, we are going to compose the function with the inverse. So part 2, I'm going to show that f composed with the inverse of x equals x. Okay, so in this composition, f composed with f inverse of x, we know that this is equal to f of f inverse of x. All right, the parent function is f of x. Whichever function comes first is your parent function, and that is 3x minus 1. Now to compose this, what we're just simply going to do is substitute the inverse for x. Okay, on the left side, the inverse is f to the negative 1 of x. And on the right side, we're going to substitute the value of the inverse into our function. So we have, instead of x, we have 1/3 x plus 1/3 minus 1. Okay, let's go ahead and simplify. If you distribute this 3 to these two terms, you end up with x plus 1 minus 1, and then plus 1 minus 1 is 0. You're left with x, and that's what we want. Now to finish this part off, we will just do the reverse composition. We will compose f inverse with f and see if we get x. Okay, so part 3, we'll have to show that f inverse composed with f is x. All right, so let's see. F inverse composed with f of x is equal to f inverse of f of x. Now let's start by writing down our inverse function. F inverse of x is 1/3 x plus 1/3. Now we're going to do the composition. F inverse, the input function is f of x, and the value is going to be on the right side, 1/3. Instead of x, we'll have the value of f of x, which is 3x minus 1. Okay, and then we add 1/3. Now if we distribute 1/3 across these two terms, we'll have x minus 1/3 plus 1/3. These two add up to 0, and you end up with x, and that shows that our answer is in fact correct. Okay, since the two composition orders yield x, then that means our inverse is correct. All right, let's take a look at question 6. It says Eric invests 10,000 in an aggressive mutual fund that pays an interest of 8% annually. How long will it take for Eric to triple his money? So the formula that we're going to be using here is the amount is equal to the principal times 1 plus the rate raised to the t. This represents interest exponential growth, where the rate is compounded over a period of time. Okay, so this is the formula we're going to use. Now let's go ahead and list everything we need and what we know. He represents the starting amount of the principal. So he started with 10,000, so that's what P is. The rate is the annual rate in decimal form, which is 0.08. Time is what we are looking for. The final amount is triple his original, so if you triple 10,000, you have $30,000. Okay, so let's go ahead and input these values into our equation and solve it. So we have 30,000 equals 10,000 times 1 plus 0.08 raised to the t. Okay, so we'll simply divide both sides by 10,000. Divide both sides by 10,000. So we have 3 equals 1.08 to the t. Now to power down this exponent or bring it down, we're going to take the natural logarithm of both sides of the equation. So the natural logarithm of 3 equals the natural logarithm of 1.08 to the t. Okay, so we power down this exponent, and we have the natural logarithm of 3 equals t times the natural logarithm of 1.08. Okay, to get t isolated, we simply divide both sides by the natural logarithm of 1.08, and that will be our final result. We have t equals the natural logarithm of 3 divided by the natural logarithm of 1.08. And we can find the approximate result by plugging this into a calculator. So if you plug it in your calculator, you get 14.27. So approximately 14.27 years. That's how long it's going to take him to triple his money. All right, let's take a look at question number 7. We are to complete the graph of f of x, assuming f of x is odd and even. Now, if you take a look at the odd situation, to complete this graph, if f of x is odd, that simply means that the function is symmetric along the origin, about the origin. Okay, so all you simply do there is you rotate the graph 180 degrees. Okay, so since this graph is symmetric about the origin, all I have to do is rotate this graph 180 degrees, and that will give me my desired result. Alright, so I just copied this image on top of the other one. So if I rotate it 180 degrees, it could be clockwise or counter, it doesn't really matter. If I rotate it counter all the way 180, so that's what the graph will be in order to make it an odd function. Okay, so just by rotating this 180 degrees, then we have an odd function. So let's go ahead and sketch what it looks like. So it's going to look something like this, just a rough sketch, and then just go up like that. So this is an example of an odd function because it is symmetric about the origin. Okay, so remember, odd involves 180 degrees rotation. Now, how about even? For even, you simply reflect it about the y-axis. So let's do that. It's just going to look something like that. You reflect it about the y-axis, and that's what it means to make it an even function. Okay, so this is the original graph we have. To reflect it, let's just grab some points. Move this about a little bit. Okay. Anyway, so just grab some points to help you with your reflection. So let's put a line here, and then put another point here, and then put another point here. It's just a sketch. So this line will help my graph look like an even function. Okay. So for odd, you rotate about the origin. For even, you simply reflect about the um, y-axis. So even reflect about the y-axis. Okay, so that's that. All right, let's take a look at question number 8. It says for the given function y equals -3 plus 4 sine pi x plus 3, find the properties and graph. Okay, so let's go ahead and find the properties. Let's rewrite it as y equals 4 sine pi x plus 3 minus 3. Okay, so we can see that this is A, this is B, this is H, and K. All right, now let's go ahead and find the properties. First thing you want to find is the center. The new center is -3 comma -3. Okay, and then that tells us the shifts. The shifts are going to be 3 units to the left and 3 units down. Your amplitude is the absolute value of A. A is 4, so the absolute value of 4 is going to be 4 units up and down from the center. The period is going to be 2 pi over B. So B is pi, so it's going to be 2 pi over pi, which is equal to 2. And then that tells us that we're going to have 4 ticks to be equal to 2. All right, now we have that down. The frequency is simply the reciprocal of the period, or b over 2 pi. So that's going to be 1 over 2. All right, let's go ahead and set up our window so that our graph will look nice. So for the window, starting from the center, -3, comma -3, we're going to go up and down 4 units. That's along the y, up 4, down 4. And then we're going to go side to side by a period, okay? So 4 up, 4 down, and then a period plus 2 to the right, and then a period minus 2 to the left. And we go 4 up, that takes us to 1. We go 4 down, that takes us to -7. 2 to the right, takes us to -1, and then -2 to the right takes us to -5. So this is what our setup is going to look like. All right, so let's go ahead and sketch our graph. It's going to be in the third quadrant. Let's see. All right, so we're graphing the sine function. So let's see how we're going to do this. We'll start with the center, -3, -3, 1, 2, 3. 1, 2, 3. So there goes the center. Our max is going to be 4 units up. So maximum will be right here. And then our minimum is going to be 4 units down. 1, 2, 3, 4. Down to -7. And then our central position will be right here. Okay, and then this is our new y-axis. Okay. All right, now that we have our setup, let's go ahead and draw a sine function. Sine function is like an S starting from the center. So you have center, and then 1 tick mark every So we have 4 ticks is equal to 2, right? So let's go ahead and graph that. So we have, for the sine function, we have 1, 2, 3, 4. That's going to be one complete period. And then 1, 2, 3, 4. That's another period. All right, so for a sine function, we'll go from a center to the max, back to the center, to the mean, back to the center, and then in the other direction, mean, center, max, center, and then that pattern basically continues. Okay, so just draw your sine function as best as you can. So it goes like that, down to the center, draw that again, down to the center, and then to the mean, right back to the center, and then that pattern continues. Okay, and then this goes down to the mean, right back to the center, and then from the center, of course, to the maximum, and then from the max back to the center, and then that pattern continues over and over again.